Hello, we have learned so far how to analyze and design rock slope against failure. This session will give a general introduction on rock slope excavation methods and the techniques. Most of the slope you see are perhaps natural slopes, for example, the hillsides and the riverbanks. However, from time to time, we have to cut the rock to mix roads, canals, and the railways. By cutting the rock away, we leave the rock slopes. In surface mining, we cut the rock to reach and mine the mineral below. Again, the open pit is surrounded by rock slopes. Those are excavated and engineered slopes. To cut or to excavate rock slopes, common rock slope excavation methods used in modern days are machine excavation, machine impact breaking, drill and blast using explosives, and the cracking by chemical to expand and break in rocks. Machine excavation is using excavator and excavation equipment to excavate and dig the ground. Typical excavation machines are power shovels and bulldozers. Excavation by machines is usually for soils and soft rocks that can be excavated by those machines. Machine excavation is effective in soft ground. Machines can dig and remove the ground rapidly, and it can excavate the ground to form a slope exactly and cause minimum damage to the slope. The limitation is that those excavation machines can only excavate ground that are relatively soft and weak. If the ground has hard rocks, machine will be damaged. When we have hard rocks, we will need to use impact machine to break the rock and then to be removed. Common rock breaking machines are rock breaker and jackhammers. They are hydraulically driven and generate impact to break and to excavate the rocks that are relatively strong that cannot be taken by shovels. Rock breaker and the jackhammer can be mobilized and used easily. Therefore, it is flexible to use. It does not involve with explosives, so have less hazards. However, as any other impact machines, those rock breaking machines generate noise and vibration that can be hazards to operators and the people nearby. Those machines may also have difficult to break very hard rocks. The most common method for rock excavation is drill and blast. Drill and blast is used for all types of rock excavations, for slopes, for tunnels, and for mines, particularly for hard rocks. The typical drill and blast procedure for rock slope excavation is first to drill the holes as designed for the slope. The holes are then filled with explosives and detonators and the stemming. The explosives are fired and rocks are fractured and broken. The video attached is showing rock blasting in slow motion. Blasting for slope is usually done by bench blast. Holes are drilled from the top of the slope down to the level of the slope toe. In fact, a bit beyond to leave some subjaw, usually about half a meter. A series of holes are drilled in such orientation and alignment to become the slope surface. Key geometrical parameters of drill holes and explosive charges are illustrated here. After blasting, the plane formed by the drill holes is to become the slope surface. To design the blast, we need to consider the bench height of the slope height, the burden of the rock to be blasted away, the hole length which should go beyond the slope toe to include subjaw, the hole diameter which also governs the amount of explosives when it is filled with explosives. Spacing between drill holes, and the amount of stemming materials covering the explosives in the hole as stem height. Those parameters are all interrelated and they govern the rock blast of the slope. I will not cover in detail on blast design and the blast operation. They are usually taught in explosive engineering course. Ideally, when we cut a slope from rock, we want 1. Technically, the slope is excavated to be stable and require minimum support and most cost effective. And 2, aesthetically, the slope is looking nice and smooth. To achieve such high quality finishing of the slope, controlled blasting is often used by means of smooth blast and pre-split blast. Smooth blast uses closer spaced drill holes and lighter explosive charges in each hole. Blast should be simultaneously, as little delay as possible, and with this technique, smooth blast is to create a smooth rock slope surface. If bench blast involves multiple layers of blast, then smooth blast is the last layer of blasting to be the alignment of the excavation of the slope face. Pre-split blasting is used to create the slope face first when there are multiple layers of bench blast. This technique involves drill a single row of holes along the designed slope face. Blast with small charges to create fractures that defines and form the slope. We produce the slope face in the rock first before removing the rock in the front. After the pre-splitting blast, then we conduct normal bench blast to blast away the rocks layer by layer until it reaches the pre-splitted slope face. Pre-split blast leaves a smooth and almost undamaged slope face, as the pre-split fracture prevented blast away from bench blasting to damage the slope rock that is on the other side of the splitted fracture. Pre-split blast generally is more costly, but it gives better finishing of the slope face. Both smooth blast and the precipitous blast reduce the blast damage to the remaining rock that forms the slope. Drill and blast for rock slope excavation is a very technical job. It requires good engineering practice to achieve good engineered slope. The good practices should cover drilling, charging, and safety. In drilling the holes, make sure holes are properly aligned, equally spaced, and parallel. During drilling, the holes may be deviated due to the influence of rock joints or long distance and become non-parallel. That will result in poor blast quality. Good design and practice of explosive charge, stemming, and delay for blasting. Use controlled blasting, smooth blast, or split blast to produce the slope face. Blast hazard should be well managed on flying rocks, noise, and vibration to the environment. Some practical guidelines on blast design are given on the right table. For normal bench blast, smooth, and precipitous blasts. We just mentioned about vibration. Vibration is a very important issue for rock blasting. Blasting generates ground vibration that could cause damage to the buildings and other structures in the vicinity area. Blast vibration must be controlled within the limit shown on the table below. Blast vibrations are usually measured and present as peak particle velocity, PPV. The PPV limits for different structures are given by the Australian standards here. Other countries have the same or very similar standards for blast vibration limits. For example, if there are historical buildings in the vicinity, vibration from rock blasting reaching the building must be not exceeding 5 mm per second in ppv. Hard rocks can also be cracked and broken by chemicals expanding in drill holes. This is done typically by drill holes into the hard rock, insert the chemicals into the hole. The chemicals, depending on the types, expanding in volume and force the rock to crack from the hole. If the holes are aligned, the cracks can form a fractured plane. The chemicals are not explosive, so they do not have the hazard of explosion. The two main types are chemical bentonite and liquid gas. Chemical bentonites, for example, bentonite shown on the right, are commonly available. They are in bentonite mix and is poured into the hole to fill the hole. When the bentonite solidifies, its volume increases and forces the rock to crack in the hole. You may have anticipated that the process is slow and the cracking can take a few days. That is perhaps the main disadvantage. Liquid gas is primarily liquefied carbon dioxide, CO2, and sometimes with nitrogen. When liquid gas is injected into the drill holes, the liquid turned into gas with a quick change of volume. The pressure from the gas pushed the hole to open and crack and fracture the rock. High-pressure water jet has been used to cut and carving the rocks. The basic principle is to use extremely high pressure of a thin water from a water jet. The high pressure thin water lacks a sharp drill to penetrate and cut the rock. The cutting is very precise, and this is why the technique is used mostly for dimension stones and carving the letters and the figures on rocks. Cutting thickness by high water pressure and the high pressure water jet is limited. Therefore, its application to large rock slope excavation is limited. It also uses large amount of water, so it makes such operation at a construction site difficult. There are trials to use water jet in combination with machine excavations and breaking. High pressure water can help to remove the rock fragments from the cutting tools and to improve cutting efficiency of the rock breaking machines. In ancient times, people used fires to break hard rocks. When rock is heated, the thermal expansion of the minerals leads to cracking. Of course, if you can heat the rock to a temperature above 800 degrees C, you may end with melting the rock, as we have learned in geology. Today, we can use microwave, millimeter wave, and the laser to do the heating for us. They are all electromagnetic waves and can heat the rock rapidly to fracture and to melt the rocks. Technologies of using microwave, millimeter wave, and the laser for large scale rock cutting and excavation are under the development. The most promising application is to pre-cracking and pre-weakening the hard rocks by electromagnetic waves radiation, so the rock can be broken and excavated by the machine efficiently. The photos on the right show how a hard rock can be micro-cracked quickly on a low-power microwave. Watch out those new technologies. I'm sure they will be eventually finding their way to hard rock excavation for slopes, tunnels, and mines. This is the end of this session on rock slope excavation method. Next session will be on rock slope reinforcement, support, and protection. Bye, and see you at next session.